Good day everyone, I am Samaneh Teimouri and I'm here to talk about modeling critical metal extraction with density functional theory using high performance computer. Indium and gallium as critical metal. So why we say that indium and gallium are critical? As nowadays everyone has a phone and other electronic gadgets in hand, hence these metals are critical. And they are key for sustainable and economic development. They are critical to the overall functionality of the end product and irrespective of the metal's quantity or total value. These metals are critical in technology and clean energy economy because of their application in electronic devices, semiconductors, solar panels, and batteries. And why is that? It's because of these metals owing remarkable properties such as being very soft, malleable, having high electronic conductivity, transparency, and ability to make a strong bond with glasses. That's why they have been used in touchscreen electronic devices. And last but not least, they have a strategic and geopolitical importance due to the different applications they have in the modern world. Indium and gallium resources and extraction. Unfortunately, indium and gallium are scarce and they have limited resources in nature because we do not have a mineral with a high concentration of these metals in it. And on the other hand, these metals have high demand because of the versatile application they have in the modern world. So what we should do is that we have to recover and re-extract them from the electronic devices that they use these metals for their production. Traditionally, acidic solutions like sulfuric acid, hydrochloric acid, and nitric acid have been used to extract metal. But more recently, there is a new solvent known as ionic liquid, which is a molten salt family, as emerging solvent can be alternative to extract these metals. So I use density functional theory to select the ionic liquid. So for this work, I chose three different ionic liquid as bemium sulfur, bemium chloride, and bemium nitrate. So I should explain this that ionic liquid is made of a cationic part and anionic part. And I choose these three ionic liquid because these three ionic liquid has the same anionic part of the commonly used acids to extract metals like hydrochloric acid, sulfuric acid, and nitric acid. And based on the calculations of Gibbs free energy and HOMO-LOMO gap, one can determine which of these ligands like sulfate, nitrate, and chloride, which provide by each of these ionic liquid, can make the most possible and most stable complex with these metals. And all of the calculations in DFT were performed using calcium-16 P3LYP function in gas phase. Here we see a homolomer of different complexes of indium with sulfate ligand, which comes from the ionic liquid bemium sulfur. And here is the homolomer of different complexes of indium with nitrate and chloride ligand. And on this slide we see the homolomer of different complexes of gallium with sulfate. And here is complex of gallium with nitrate and chloride ligand. And after calculating the Gibbs free energy and the HOMO-LOMO gap for indium, it was found out between the 9 different complexes of indium, which was made of with these three ionic liquid. The dimer complex of indium with sulfate ligand has the lowest Gibbs free energy and highest HOMO-LOMO gap. And the same was concluded for gallium. The dimer complex of gallium with sulfate ligand has the lowest Gibbs free energy and highest HOMO-LOMO gap. And as you know, the low Gibbs free energy is indicating the higher possibility of that complex to form, and a high HOMO-LOMO gap showing the high stability of that form complex. But some of you might say that still the Gibbs free energy is a positive number. I want to assure you that I did this experiment in a lab scale to extract indium and gallium using ionic liquid. And in a lab scale, when you have the solvent and temperature, so these driving force make the reaction to happen. And here is the optimized geometry of the dimer complex of indium and gallium with sulfate ligand. And thank you so much for listening to me. Again, I'm Samaneh Teimouri, and this is my LinkedIn information and my email address if you want to contact me.